Let's consider the example of aluminum oxide a bit further. We said in the previous video that its empirical formula is aluminum 2O3. But how do we know that? Well, when pure aluminum metal is exposed to oxygen, it will attach oxygen atoms onto its surface, forming aluminum oxide.
Oxidation of the aluminium occurs almost instantaneously, and the reaction proceeds more quickly if the flask is full of oxygen rather than air. The process of the reaction has been filmed by time-lapse photography. This short 1-minute long sequence was filmed over a 2-hour period. The product of the reaction is an oxide.
This experiment can be used to determine the empirical formula of aluminum oxide. All we have to do is weigh the aluminum powder before we use it to form the oxide, and weigh the oxide once it is formed. Let's say the mass of the empty container in which we will perform the experiment, a round bottom flask, is 117.84 grams. When we add aluminum powder to it, we find that the mass increases to 118.38 grams. The mass of the aluminum powder is the difference between the mass of the container with the powder and the mass of the empty container. So the mass of the aluminum is 118.38 grams minus 117.84 grams, and that is 0.54 grams. After we have formed the aluminum oxide, we can weigh the flask once more. We find that its mass has now increased to 118.86 grams. By subtracting the mass of the empty flask from the mass of the flask with the aluminum oxide, we find the mass of the aluminum oxide. The mass of the aluminum oxide is 118.86 grams minus 117.84 grams. It's 1.02 grams. Why is the aluminum oxide heavier than the aluminum metal that we started with? Pause the video for a moment and think about it. Because the aluminum atoms attached some oxygen atoms, the mass of the aluminum oxide is the mass of the aluminum that we used plus the mass of the oxygen that it attached in order to form the oxide. Therefore, the difference between the mass of the oxide and the mass of the aluminum that we used is the mass of the oxygen that attached to the aluminum. So the mass of the oxygen is 1.02 grams, the mass of the aluminum oxide, minus 0.54 grams, the mass of the aluminum, and that equals to 0.48 grams. So now we know that 1.02 grams of aluminum oxide contains 0.54 grams of aluminum and 0.48 grams of oxygen. Dividing the mass of the aluminum by the mass of the aluminum oxide and multiplying the result by 100% would by definition give us the mass percentage of aluminum and aluminum oxide. Similarly, dividing the mass of the oxygen by the mass of the aluminum oxide and multiplying the result by 100% would give us the mass percentage of oxygen in aluminum oxide. However, what we are looking for are not these mass percentages. Rather, we want to find the empirical formula of aluminum oxide that, by definition, gives the simplest whole number ratio between the number of atoms of different elements in a chemical compound. To find the empirical formula, we need to find the ratio between the numbers of aluminum atoms and oxygen atoms in aluminum oxide. We know the total mass of all aluminum atoms in our sample of aluminum oxide, 0.54 grams. If we divide this value by the molar mass of aluminum, we will get the amount of aluminum. That is the total number of aluminum atoms in moles. Moles of aluminum is going to be 0.54 grams divided by 26.982 grams per mole, and that is going to give us 0.020 moles, or in scientific notation 2.0 times 10 to the minus second power moles. Similarly, we know the total mass of oxygen in our sample of aluminum oxide, 0.48 grams, and if we divide this value by the molar mass of oxygen, we will get the amount of oxygen. So the number of moles of oxygen is 0.48 grams divided by 15.999 grams per mole, and that is 0.030 moles, or in scientific notation, 3.0 times 10 to the minus second power moles. Taking the ratio of the number of moles of aluminum to the number of moles of oxygen in aluminum oxide, we find that it is 2.0 times 10 to the minus second power moles to 3.0 times 10 to the minus second power moles, or 2 to 3. That is the smallest whole number ratio. Therefore, for every 2 moles of aluminum atoms, there are 3 moles of oxygen atoms, or for every 2 aluminum atoms, there are 3 oxygen atoms. The empirical formula of aluminum oxide that we determined from this experiment is then aluminum 2O3.